All right, so problem one. We have a lamp with a mass, and there is a force of gravity is pointing downwards, so it's going to be force sub h, or you can just put mg, right? Mg. So here, let's just erase. Yeah. So there's the mass. There's a string, all right, a tension string pulling it in the negative x direction. And then there's also a hinge force here, right? Okay, so all of these things are balanced in all the sum of the forces are balanced in such a way that this object is not shifting up or to the, it's not shifting vertically or horizontally. So it's stuck in place, meaning all the forces are going to cancel out. Also, it's not rotating, so the sum of the torques is going to cancel out. Now, I like to start with the sum of torques. So looking at all of the forces here, we got FH, MG, and T. Now FH, since there's the pivot point and it's coming directly from the hinge spot, the radius is 0, so we won't include that in the torque. Now T is a distance V away from the pivot point, and it's acting 90 degrees to the distance, right? The radius from here to here, and T is this way. So sine of 90 is 1. We don't have to include that. But which way is this tension going to rotate this, right? It's going to be rotating it counterclockwise. Now, if you want to use the thumb rule, right, you take your hand up in the direction of the radius, and then you bend your fingers in the direction of the force, and your thumb points up, so it's going to be positive. So we're going to have the radius is V, the force is T. Now over here, right, it's a distance H away, and mg is pointing down. So if you take your hand in the direction of mg and point down, your thumb will be pointing into the page. So that's going to be a negative torque. Another way to look at it is this mass will cause this thing to rotate. If it was allowed to rotate this at this hinge joint, it would rotate it clockwise. So we're going to have negative, okay, distance is h, but h is 4v. So we'll have negative 4v, right, times mg. The force is mg. And that is equal to 0. Now, add this to both sides. You got vt equals 4v mg. Divide both sides by v, and you got t equals 4 mg. So now let's look at the sum of the forces. So we're going to look at the mass here, right? So what forces are acting on the mass? We got mg this way. We got T, right? T, there's it's pulling on the mass this way, right? Through an extended medium or body, I should say, right? It's transferred through this body to here, but it's really acting on this. And then you got the hinge joint that's acting like this, but you're only going to be looking at the X component and the Y component when you're trying to solve here. So you can either write just that single vector that way, or you can erase it and put the X component and the Y component. And so this is mg, this is T. So you can see here, right? The sum of the forces in the X will be hinge force in the X minus T equals mass times acceleration in the X. And since it's not moving, it's 0. So we see here that we'll see here that FHX, right? F sub HX equals T. Now what is T? F sub HX is T is 4 mg. Remember, you want all your stuff in terms of mg. Okay. Sum of forces in the Y now. That's going to be positive F. That's an HY, not just Y. Force of hinge in the Y minus just mg equals mass times acceleration in the y direction. The acceleration, it's not moving, so it's 0. So we got F sub hy equals 1 mg. Okay. So you can use cosine and sine if you want to. But that's a long process because you got to go through tangent and stuff. So the way to find the hinge force, the actual hinge force, is the hinge force is going to be equal to the square root, right? So the magnitude of this, not its direction. We haven't really found its direction. The magnitude, how much force this is in this direction here, is going to be force of hx squared plus force of hy squared under the square root. And so that will be, right, square root of, what was that? Yeah, 4 mg squared plus 1 mg squared. That will be, right, 4 squared is 16, 1 squared is 1, so 16 mg plus 1 mg under here is going to be 17 mg squared. So we got square root of 17 mg squared. So then coming out of the square root, right, this just becomes mg, this stays square root of 17. So we got, here, I'm going to write it right here. Hinge force is going to be square root of 17 times, right, just mg, because we pulled mg squared out of the square root. Okay, so now that was part 1. Part 2 is find the angle. So angle, we're going to be using the inverse tangent. Okay, here, let me start over. I'm jumping the gun. Tangent of theta is the opposite force over the adjacent force. So that would be Fhy over Fhx. Okay. Now, theta equals, right? Keep theta over here, and it's going to be the tan inverse of this equals inverse tan of Fhy over Fhx. And that would be the inverse tan of Fhy was just mg, and Fhx was 4 mg. Okay, so it'd be the inverse tan of 1 over 4. Okay, and that is, grab my calculator, inverse tan of 1/4 equals 14.0304 degrees. 14.04 degrees. So this force, right, at the hinge, looking at this, here's the wall. Here's the wall, and the force at the hinge would be something like this, right? And here's the horizontal line. So that angle would be 14.04 degrees.